Hello everyone, in this video we will go over the solution to participation number 1. In question number 1, the method that we need to use is the integrating factor method. So remember that if you have a linear ordinary differential equation that looks like this, p of x y equals to q of x, the integrating factor will be e to the p of x d of x, and then you multiply everything, you multiply both sides by the integrating factor, and then it should be easy to integrate both sides. So here for p of x you have 2 over 4 minus x, and for q of x you have or you can use lowercase, it doesn't matter. Okay, so for q of x we have just the number 5. Okay, so to find the integrating factor, this will be e to the integral of 2 dx over 4 minus x. So remember from calculus 1, if you want to integrate this is just a basic substitution where u will be 4 minus x, so the u will be minus the x, so this will be minus 2 the integral of the u over u, which will be minus 2 ln of u, or minus 2 ln of 4 minus x. Right, therefore the integrating factor will be e to the minus 2 ln of 4 minus x, and then from the rules from pre-calculus, remember you can write it like this. So therefore this is the same thing as 4 minus x to the negative 2, or 1 over 4 minus x squared. Okay, so now we multiply both sides by that, so you're gonna have 1 over 4 minus x squared times the original equation, and you multiply it in the other side too. And remember that the left side is easy to simplify, and the only part you have to technically integrate is the right side. By that I mean that this is going to become the integrating factor, which is this, times y prime, and then this side you have 5 divided by 4 minus x squared. Next, just integrate both sides, and remember when you integrate a derivative they cancel each other, so from this side you will only end up with 1 over 4 minus x squared times y. Now the integral of the right side, you can do a substitution again, so technically you could say one more time that u is 4 minus x, so the u will give you minus the x. So this is the same thing as integrating 5 over u squared with a minus sign in front, or the same thing as integrating minus 5u to the negative 2, which it will be minus 5u to the negative 1 divided by negative 1, so the negatives cancel, so it will be just 5 over u. So we will do that, then this will become just 5 over 4 minus x, and then you need a constant. Now the initial condition says that y of 0 is equals to 4, so this implies that 1 over 4 squared times 4 is equals to 5 over 4 plus c. Okay, from here we have that 1 4 is equals to 5 fourths plus c, which implies c is minus 4 over 4, or negative 1. Now, finally, the last step is you need to leave y by itself. So to leave y by itself, you need to multiply both sides by 4 minus x squared. So if we do that, so you multiply by 4 minus x squared on both sides, we end up with this. On the left side, you have y, which is what you want, and the other side, you're going to have 5 times just 4 minus x, and this would be now minus 1 times 4 minus x squared. And that's it. There's no need to simplify anymore. Alright, now let's look to number 2. Mickey Ratz claims that y prime equals to xy minus 5y is a separable differential equation and linear. Is he correct? Well, kinda. So let's see this. So let's say case 1. If we write the equation like this, y prime you can say plus 5y plus or minus xy equals to 0, then you can write it like this. This will be y prime plus, you can factor the y, and then this will be 5 minus x equals to 0. So in this case, p of x will be 5 minus x, and q of x will be 0. So therefore, yes, this will be linear. Okay, so that is correct. Now, also from here, you can say case 2. If we rearrange this is the same thing as, you can rewrite it like this. Hold on. It's the same thing as minus y, and this will be x minus 5 now, equals to 0. So this will be y prime equals to y over x minus 5. Or you have the y over the x equals to y over x minus 5. And you can clearly separate this. This will be the y over y. And then it will be x minus 5, the x. So therefore, yeah, he is correct. This is separable. So far, Mickey Ratz is correct. However, if you look to case 3 and you rewrite the equation like this, y prime minus 5y or plus 5y equals to xy, or you write y prime minus xy equals to minus 5y, then because of the y in here, this is not linear. You still can solve it using the separation, the separation method or the integrating factor, but because of this, it's not linear. So therefore, he's 90% right, but not completely right. If the equation was just written like this or this, and you cannot rewrite it, then the equation will not be linear because of the y on this side. Remember that q is supposed to be a function of x only, but now here q will be a function of x and y, even though there is no y. Same thing here. So that's why this is not linear, if it is written this way. So technically he's correct if you write it this way or this way. Otherwise, Mr. Ratz is wrong.